Welcome back, mathematicians. In this video, we are going to talk about the conic section parabolas. A parabola is the collection of all points P in a plane that are the same distance d from a fixed point F as they are from a fixed line D. Let's use the diagram below to illustrate the relationship of the parabola and its attributes. So let's first identify the fact that the vertex is on the origin. There exists a line of symmetry for all parabolas. In this case, the line of symmetry is the vertical line that goes through the vertex, which we also call an axis of symmetry for the parabola. The fixed point F is called the focus, and the fixed line D is called the directrix. So the definition tells us that the distance from the focus to any point on the parabola, we'll call that distance D, is the same as the distance from that point P to the directrix. So this is also a distance with the value of D. And so that is true for all points on the parabola. As a result of that definition, there are actually 4 versions of the parabola. So we are going to look at all versions where we have a vertex on the origin 0, 0, a focus is on an x or y axis, and the value of a, which we're going to talk about in a minute, is going to be greater than 0, meaning it's positive. For each of these, again, the vertex is on the origin, so that's why the first column, all of them are the ordered pair 0, 0. And I'm not really going to read through this table and also the corresponding graphs in great detail. I'm going to focus on the relationship and patterns that we should hopefully identify from this table and their graphs. So if the first two are opening to the right and left, and what we notice here is that the equations are both y squared, or they have the y variable squared. We also notice that the focus is on the x-axis, and we notice that the directrix is a vertical line at either x equals a or x equals negative a. This is different if the parabola were to open up or down. If it opens up or down, the x variable is the squared term. In this case, the focus is on the y-axis, and the directrix is a horizontal line either at y equals negative a or y equals positive a. The graphs below illustrate all 4 versions, where we have the first version, it opens to the right, second one opens to the left, third opens up, fourth opens down. What I'd like to focus on, however, are a couple things. First, and most notably, is the value of a. A is the distance from the vertex to the focus, and the distance from the vertex to the directrix. So that is a distance of a units, and it is true for all 4 versions. So this is a, and this is also a distance of a units. You will also notice that the directrix is perpendicular to the axis of symmetry. In this case, the axis of symmetry for the first graph opening to the right is the x-axis. The second version, same thing, the axis of symmetry is the x-axis. The third version, the axis of symmetry is the y-axis, and then the fourth version, where it opens down, it's also the y-axis. So again, the directrix is always perpendicular to the axis of symmetry. You'll also notice that the foci, or the focus on each of these versions, is on the axis of symmetry, and so is the vertex. One more attribute to discuss: when graphing a parabola, it is helpful to determine the opening, or how wide or narrow the parabola is, by finding the points that lie directly above or below, if it's opening to the right or left, or right or left of the focus if the parabola was opening up or down. The line segment joining these 2 points is called the lattice rectum. So that's another attribute of our parabolas. So in the diagram here, I have a parabola opening up. I have the focus on the y-axis, and the points that are on the parabola that are directly to the right and left of the focus are these 2 points right here. And if you draw a line segment between those 2 points, which would also contain the focus, that is called the lattice rectum. And so those 2 endpoints allow us to know how wide or how narrow this parabola is, and they become vital when graphing a parabola. Let's now do an example where we are asked to find the directrix, vertex, focus, and endpoints of the lattice rectum for the parabola that's given. I'm giving you an equation of a parabola, which is x squared is equal to negative 8y. So if we go back up to the table and look at our 4 versions, we see that this one matches the version that opens down. So we know that this is the same as x squared is equal to negative 4a times y, and the parabola opens down. We also know, because there is no horizontal or vertical shift with this equation, that the vertex will be on the origin. So that's the first item we can identify pretty quickly. Next, we need to find the focus and the directrix. To do that, we have to understand where they are located. I'm using the figure to illustrate this. It's a rough sketch, but you get the idea. So I know that the focus will be a units away from the vertex. I also know the focus should be on the y-axis because the y-axis is the axis of symmetry. I also know, if you think of the parabola as being like a bowl, I know that the focus is inside of the parabola. I also know the directrix should be perpendicular to the axis of symmetry, and it's going to be a units above the vertex. So this distance right here should be a units, and this distance right here should also be a units. So as you can see, finding the value of a is very important. What we know, because of the formula above, is that negative 4a is equal to negative 8, which means a is equal to positive 2. This is enough information for me to identify the ordered pair for the focus and also the equation for the line that is the directrix. So for the focus, we know that the ordered pair will be 0, negative 2. For the directrix, we know the equation, since it's a horizontal line, it should always be y equals, and y equals a constant. In this case, the constant is a value of positive 2. The last item we were being asked to find are the endpoints to the lattice rectum. That means I need to find these 2 points that are on the parabola that are directly to the right and left of the focus. Because these 2 points are directly right and left of the focus, by the way, I'm going to abbreviate lattice rectum as LR. Because these 2 points are directly to the right and to the left, we know that they share the same y-coordinate. Because they all share the same y-coordinate of negative 2, I can then replace the y variable with the value of negative 2 in the equation, so I'll have x squared is equal to negative 8 times negative 2, and I can solve for x to find the x coordinates. This means that x squared is equal to positive 16, which means that x is equal to plus or minus 4. So therefore, I know that the endpoints of the lattice rectum are at positive 4, negative 2, and also negative 4, negative 2. All right, guys, good luck.